familiar with OpenStack? Who here was at my last talk? I see a couple of familiar faces. So, what are you doing being secure? Just leave me alone right now. So I'm going to cover OpenStack, and this is going to be a deep-ish dive. A deep dive would involve opening up all the configuration files and tearing that all apart. OpenStack is cloud software. It's designed around the idea that you don't really care about any hour or 2 hours or 5 hours is unrealistic. You got to kind of take it piece by piece, digest the information that you get, and then move on. It really helps out to play with the software. It really helps out to kind of have a little bit of knowledge. So once you go through each topic, you'll learn that topic, and then we can move on. We can move forward. So what is the cloud? Cloud computing, on-demand computing. It was really created, I believe, by Amazon, and NASA and Rackspace also had some technology known as OpenStack, but Amazon is really the first people to come up with the cloud. And it's on-demand computing. So if I need a virtual machine to perform a task, I would fire up a cloud machine. It would do its task, whether that task is 30 seconds, 3 days, 3 months, 3 years, whatever the task is, it's on-demand computing. So I don't have to maintain a whole bunch of infrastructure just to solve my virtualization problem, because there technically is no cloud. There's only somebody else's computer. So clouds are kind of put together in a few different service models depending on what service you're looking for. So if you're looking for infrastructure as a service, that's what OpenStack is. Infrastructure would be like, I need a network, I need a load balancer, I need a virtual machine. Platform as a service is where you would run an application. So if you want to run a custom Java application, you could run that in a platform as a service and not have to worry about any of the underlying layers. You really only care about your app. Software as a service, so things like Office 365, Salesforce.com, those are software as a service where you're gathering your own tenant of software to run, and it acts like you're the only person there, but realistically it's an application hosted in the cloud, and they're software as a service cloud. And then random things as a service, because who knows who's going to come up with what is the next acronym for as a service. Everything is as a service. Your terminology? But this is my terminology. Yeah, random things as a service is not a real thing. Don't go Google that. That's not going to work. So infrastructure as a service. What is infrastructure as a service? So infrastructure as a service, like I said, is if you needed a virtual machine, if you needed a network resource, so let's say you wanted to do your load balancing out in the cloud instead of having an internal load balancer, or you had several different data centers across the country and you didn't really want to maintain a load balancer, you could use a cloud-based networking application. The CINDER volume service is a example of infrastructure where I just want a bare disk. I just need a block device, and I'm going to connect it to whatever I want to connect it to. So this is super unimportant, to be honest. We already covered that. So OpenStack is really just infrastructure as a service. That's what it's aimed at providing, is that infrastructure layer where I can grab a resource, use the resource for as long as I need it, and then kill it and not worry about what's going on or have to worry about the internal wiring or how it works. So if you guys are interested in testing out OpenStack, you can go to rdoproject.org, and the RDO project has got a semi-production version of OpenStack. It is the upstream for Red Hat's Red Hat OpenStack platform, but RDO is used by CERN. Who in here familiar with CERN? Has anybody ever heard of that organization? They run the Large Hadron Collider, gather massive amounts of data. They actually use RDO for their OpenStack build, and they've got 3 guys that maintain several thousand servers using OpenStack. So we're going to go kind of through each bit, and each one of these projects has got some crazy name associated with them that makes absolutely no sense. Maybe Nova makes sense, but not. I can't understand how. So all these projects are individual projects within the OpenStack confine, within the OpenStack foundation. So they're managed projects. They get a rating inside of the project as to how stable it is or how good it is. And each one of them performs an individual task. So you see this horizon bar that goes across here. That's just the UI. It's an example of what a user interface should look like or could look like. What they expect you to do with Horizon is grab the code and customize it yourself. Keystone is the identity service, Nova is the compute service, Glance is the image service, and all these are infrastructure bits. Those are things that you would have in a legacy infrastructure. If you were to compare cloud versus OpenStack, an image would be an ISO on a disk that you burned out to a physical DVD, and I go stick it in a DVD tray for a server and tell it what to do and tell it to spin up. So, yes.
One thing about your diagram there is that the keystone is so important. I mean, if keystone breaks on any one of those, it's not going to hook into it.
So everything is authenticated, and that's what Keystone does. Yeah. It's an identity manager. So it not only does it manage the identities of tenants inside the cloud, and we'll talk about tenants in a little bit, it also manages all the service accounts as well. So if Nova wants to do something, it has to authenticate. Everything is authenticated. So everything is based off of a RESTful API inside of OpenStack, and everything is done via an API. And that's kind of what makes it unique in some of the first software of its kind. So it's not the only software like that, but...
Is it safe to assume that Keystone can be distributed for fault tolerance? So like, if Keystone is the choke point of your system?
Absolutely. All of these services, so if you think about OpenStack, don't think about it as it actually doing something more so than providing an API to do something. So this gives you a standardized API. So we'll take Nova, for example. The API that Nova offers you is a standard way to access compute resources. So if I want to spin up a virtual machine, no matter whether the hypervisor is KVM, VMware, Xen, any one of the supported hypervisors that can go on the back end, the Nova API defines for how you will fire up a compute instance. So you'd say, Nova, I need you to start a virtual machine, make it look like this. And that's what the API provides you. So you've got this front end to several different back ends. And each one of these can scale individually. So if you are having a heavy load on your authentication requests, or you have a very large cluster, you could absolutely load balance any one of these APIs and have several of those servers or several of the services. So in a typical production cluster, there are no less than 3 controller nodes. A controller node is defined as something really that has all the API services on it. And then it uses RabbitMQ on the back end. So this talks to other services inside of OpenStack. So the API is the front end. There's a RabbitMQ message queue that communicates inter-process. So the Nova Compute service talks to the Nova Console Auth service or the Nova Conductor service, and that's how those actions are performed. I know that's a lot. Anybody have any questions on any of that? So Horizon, like I said, this is it's just a dashboard. There's nothing special about Horizon. It's the Django dashboard. It's maintained, and it shows how you can use all of the functions that exist in the OpenStack API. So there's not anything that you can do within the command line that you can't do in the UI. Sometimes you have to figure out how to do it and where to do it from, but it's an example. It's not supposed to be like a production dashboard. You're not supposed to use that. Any questions on that? So this is what the dashboard looks like. This is actually tristack.org, and we're going to go there and we're going to kind of check it out. So Nova, this is probably the most important service, because what do most people want out of the cloud? They want virtual machines. They want to be able to fire up virtual machines, and they want to be able to run their virtual machines and manage those machines. And the Nova service, or the Nova project, is what's doing the actual compute. So compute could be, like I said, several different hypervisors, but Nova is the front end for all of those hypervisors. So it interacts with every other service. So if I have a compute instance that I want to start, it kind of needs a network to come up. It's going to need a network resource. It might need block storage. it might need access to the image service to pull down that image. So Nova is really the most important service out of all of OpenStack. And Nova is broken down into 6 different parts on the back end of that, where it's got the API in the front end, and then it's got several other worker services that come along with it that perform different functions. So if you want to use the web-based UI console to access your virtual machine, Nova handles that. The Nova NoVNC console service interacts with the API, authorizes it through Keystone to give you access, console access to that virtual machine. You can communicate with several different backends, like I said. The Keystone is kind of an important service as well. So Keystone is where everything is authenticated, and you can federate Keystone. You can scale Keystone very well because it's really a front end, an API front end that connects back to either a SQL database or an LDAP, some sort of LDAP system. And the LDAP system could be Open LDAP, it could be Free IPA, it could be Active Directory, it could be whatever authentication backend that you want to use. And you can also scale it for multiple domains. So let's say I have test in dev.org and production.com. I could have 2 different domains to authenticate 2 different groups of users to manage that infrastructure. And they can be in completely separate LDAP structures. They could be in the same LDAP structure, separated out into separate groups. Keystone really provides you that granularity to authenticate absolutely every action that happens within the cloud. So everything that's going to be done needs to be authorized via the API. Any questions about the Keystone service? Okay, moving on. Glance. So Glance is like the registry, or if you think of that old school ISO burned out onto a DVD, this is where all the images for everything that I will do, every virtual machine that I will start, is held within Glance. Also, all your snapshots. So if I have a machine running and I want to take weekly snapshots of that machine, those snapshots are also stored within the Glance service because that's for images. If I wanted to fire up an image based off of a snapshot, I could use the Glance service to do that. It supports several different formats. Most of what people are interested in are these 2 formats down here, QCOW2 and ISO. So using ISOs within the cloud, there's a couple of different things that you have to do. It's not like a traditional infrastructure where you're plugging in a CD-ROM drive. It doesn't have any concept of that. It has a concept of an image, a bootable image that's going to do something. So if that bootable image is an ISO, think about it, if I put my hard drive in my computer and that was the only drive it had, or I put my CD-ROM drive in my computer and that was its only drive, you can't really do a whole lot else that's not contained within that ISO. It's usually not a writable drive. So if you use ISOs to build your virtual machines, you have to connect some other storage to install the software to, in your non-traditional fashion. But most people, most vendors are putting out a QCOW2 image. I mean, there's not a Linux operating system you can't get a hold of on QCOW. And also Windows puts out a QCOW image too. So there's a company called Cloud-Based Solutions, and they have a Server 2012 image, and Microsoft has authorized them to create this image, and people can run it for free for 30 days. So if you keep snapshotting and rolling back, maybe change your time, I don't know, you could run Windows Server for an indefinite period of time using their image. It also supports Cloud-init. And Cloud-init is a very important process within OpenStack. It's how the machine is configured. Yes?
Could you explain a little bit on I'm not familiar with QCOW2 versus like ISO. I understand that you like have to take a step to install it on some block storage, but how does QCOW2 operate? Like, is it writable? Is it? I don't really get it.
Right. So QCOW2 copy on write version 2 is a bootable image. So this is a bootable, writable image of an operating system that somebody has designed to run inside of a virtualized environment. Most of the QCOW2 images for OpenStack are for OpenStack, and since it's kind of standards based, and there is a standard, there is a way to build an image for OpenStack, which essentially just includes creating a virtual machine and then installing Cloud-init on it and then loading it into your system. That image is bootable and customizable. So when OpenStack creates a virtual machine. It takes a copy of this QCOW2 image, puts it into the Nova service, and then creates another writable layer on top of that. So it uses this base image, but it never changes it. It leaves that base image exactly how you left it. And that's how the snapshot functionality works as well. So if you take a snapshot, it will copy over this base image, that snapshot copy, and then another copy on right layer in front of that.
So it's a union file system with instantiated?
Yeah, something like that. It really uses pointers to point to another QCOW2 image. So within the image itself, it points to another QCOW2 image within the file system, the hypervisor.
And then it says AMIs on here. So can Amazon be a provider to OpenStack? Can OpenStack use it for cloud bursting? Or?
Honestly, I don't have a good answer for that. Maybe you could comment a little bit more
You can
on
tie
it.
in OpenStack to Amazon in such a way that even the Moto library, Python library for interacting with Amazon can actually interact with OpenStack.
So you could have OpenStack on-prem and you need extra resources. Burst through OpenStack to Amazon.
Yep. And
So, I mean, that would be working the direct opposite direction with an AMI, though, so you'd be pulling out of the cloud into your local data center.
the interesting thing there about cloud init is exactly how Amazon sets up their instances cloud init as well. So it's a very underestimated project, that cloud init.
Right, yeah, it's the linchpin of the whole cloud environment because you can put all kinds of different variables inside a cloud init, and we can go over that a little more in depth.
We could go more in depth in that, where you find a good spot to do it.
Right, yeah. Well, I mean, this is a pretty good spot to do it because we're talking about imaging. So Cloud Init is really that. It's a service within the Linux machine or the Windows machine that talks back to a metadata server. And the metadata server is at a multicast IP address? I can't remember what it's a multicast IP.
It's a
standard
local,
IP, yeah.
local cast, but
Yeah,
it's set up in such a way by the actual host that the virtual machine is on.
Right, and Nova hosts that metadata service, and that metadata service, you inject things down into it, like yum install XYZ. I could load a bash script. I could tell it to run a curl on some script I've got hosted out on GitHub or something, and it will just do that. And that's really what makes the cloud possible. So your application, when it's being overloaded, or you want to scale out, you have your application talk back to the cloud and say, hey, fire up this other machine and make him look just like me, and that's accomplished through the metadata service in Cloud Init. Is that about right? Yeah. No, I don't have really anything else. You can also do VHDs, VDIs, VMDKs. I don't really uses those with OpenStack, and I can't vouch for the functionality of them because I've only ever used QCOW2 images. I've really tried a VMDK in OpenStack. It says that it's supported.
If you have a virtual machine from VMware, you can convert using the tools to QCOW2 or whatever.
So it's also important to note that, so if you have a VMware backend as your VMware hypervisor, you might want to use VMDK because that's important to you. Whereas if you have a KVM backend, you might want to go ahead and go with QCOW2.
Or use image convert to convert it to the other.
You absolutely could do that. You could use the QEMU tools that are included in Linux to convert in between varying disk formats. There's also VertV2V, which is uses libguestfs to create a copy, to create an image of an image, and then write things to it, create it, or change parameters inside of it so it would run in another environment.
Well, what was the name of that?
It's VertV2V.
VertV2, number 2?
Number 2, yeah.
VertV2V.
Number 2, VertV2V. Yeah.
I'll be enough searching on my Fedora machine.
Yes, yeah. VertV2V has got all those tools to do conversions in between different systems. So you convert, if you wanted to get your machines out of VMware, you could connect VertV2V to a VMware data center. You have to have vCenter running though. It won't work on the standard ESXi.
Because it needs to pull the metafile.
Well, it's just because ESXi doesn't have a rich enough API. It's really just a hypervisor. Like KVM's just a hypervisor, doesn't have any other functionality in there. And maybe he's made some advancements. I just haven't checked it out since for a while.
Hyper-V is Microsoft's, right?
Yeah.
So OpenStack runs on Hyper-V.
You could use Hyper-V as a backend. I know there's some caveats to that right now. They're still working through some of the bugs, but I believe you can use Hyper-V. I've never tested it personally, but you could use Hyper-V as a backend if you wanted to, and that's where the VHD style of image would come in with the glance service.
Like even with the platform as a service stuff, so Microsoft is going to release their own flavor of Docker, probably within the next 6 months or so. So those Docker images have to be compatible with the kernel they're running on top of, so they'll only run on Windows hosts. But you can have Docker on Windows as well as Docker on Linux, and you can mix those in a consistent environment. So.
Right. Well, OpenStack would allow you to create regions and define a region as a KVM region. This is a VMware region, and this is a Hyper-V region, and then your workload can be deterministic and where it's going to go. It's like, okay, I'm a Windows workload, I need to go over here. And that's the whole. That's one of the premises behind the cloud is that there's not a guy clicking, typing, doing anything. It's the application talking back to the cloud itself. That's the ideal way to do it. So Glance can also store all these images in another OpenStack service, the object service. So the Swift is the object storage. I'm gonna move on to Swift so we can talk about that at the same time. Yeah, we'll come back to the rest of those. So Swift is the object storage service, and objects are just blobs of data, ones and zeros. They just blob these data together, break the bits apart, and keep metadata on where all the blobs are at. So it can get replicated all over the place and give you a massively scalable file system. It's important to note that it's scalable. It doesn't exactly mean that there's good performance. But you can store your Glance images in this object store, so you only need one storage backend for your cloud. So that way when you're building everything and you're trying to put together a production cluster or even a reasonably sized dev cluster, you don't have to have all these different types of storage arrays or rely on some sort of local storage mechanism where you can use one storage system to unify all that and just do that once, because storage is its own whole thing. And the Glance service does support using the OpenStack object storage service to do that, store its images. When you start talk about users making hundreds of snapshots, daily snapshots, hourly snapshots, whatever they're doing, you can start to chew up a lot of space very fast. The default installer puts all these images in var lib glance images. That's the directory and the file system where it will put it. So if that directory is connected to an NFS server, then you could put it on shared storage as well. If it was an iSCSI disk, you could do that. But that's the directory where all the images are stored, is var lib glance images. NEUTRON is almost not a train wreck now. It's so close to not being a train wreck. It's so close.
We're connected now.
NEUTRON, there has been a lot of work. Cisco has done a lot of work to unmess up NEUTRON. NEUTRON's, the whole purpose behind NEUTRON is so somebody doesn't have to go down and plug any cables in, they don't have to create any VLANs, they don't have to do any actual work. They can point and click in the UI, or they can use the API to spin up networks that don't exist. Just like you could spin up virtual machines that don't exist, with NEUTRON you can spin up networks that don't exist. The default and the recommended way to do that is with VXLAN. VXLAN is extended VLAN. It's essentially GRE and VLAN combined, so you get 65,000 different tags that you could put on a packet as it's coming in and out of a network, as opposed to 4,094 that you could do with VLAN. So it's very important to have some sort of network system that's able to scale very well, because VLAN doesn't scale very well when you open it up to the public. That's how you segment traffic. So each tenant, let's say Rich is a tenant inside the cloud and I'm a tenant inside the cloud. I don't want him sniffing my network traffic. I don't want him to have layer 2 access to my machines. He could put a sniffer virtual machine in the network and sniff all the packets that are coming across the wire. So you got to separate that traffic out, and that's one of the main functions behind NEUTRON. Some more functions that are coming. Some of them are in the newest release of OpenStack and Mitaka. So it also allows you to create a router that's more than just essentially NAT. So the initial idea behind a router, what they called a router, was really a NAT device where you have a public IP and a private IP. And the public IP is literally publicly accessible. Like, you can get to this IP address from the entire internet. And you don't want everything just going to your virtual machine. You don't want to attach that public IP address directly to your virtual machine, because now everybody has access all the way through your infrastructure to the hypervisor. You want to stop that at the edge so that traffic does not come inbound. And the initial idea behind a router was essentially just a source NAT device that runs on the controller node. So any packet inbound for the public IP address would be source NATed back to that private IP address. Are there any questions on that?
Yeah, I got a question.
Yes.
So you mentioned extended LAN has 64,000.
65,000 or something.
Yeah, to the whatever power that is.
Yeah.
60.
So my question is, like, a big vendor, let's say Rackspace. I know Rackspace uses OpenStack. Are they able to use NEUTRON? Like, it seems like they have more customers than the allotted extended LAN would offer. And I'm curious, like, how does a customer that big manage network? Maybe you have no idea. I don't know. But
So
how would they manage networking? Or am I misunderstanding a little bit about what extended LAN is all about?
Well, no. I mean, they just wouldn't. So if they went to the old school VLAN style, they would have to have several different silos of networks and then an edge router to manage all of that traffic. Where with the extended LAN, they don't have to have as many of those.
Like bigger regions.
Silos, yeah, larger regions, yeah. That would be how you would. That's how I would segment it out. I don't know the inner workings of Rackspace, and that's kind of what makes them their own special little thing. That they do what they release code as they want to, because it was NASA and Rackspace who really created OpenStack and like got the OpenStack project off the ground. It's Rackspace. Mostly, it started out as Rackspace code, so they might have something we don't even know about yet.
So you mentioned the release name, so there's like the vendor releases. What release name are they on? Then like what's RDO on, and then what's on like OpenStack, .org.
So every vendor moves at their own pace and distance with their releases, and what they do is they just take the OpenStack code. Most of the vendors take the OpenStack code. They make sure that it works. Like if a feature doesn't work, they just won't include it in that release, or they'll just wait a few months for that code to be stable or that feature to be stable before they release it. But upstream OpenStack is only source code. They provide no compiled binaries at all. You are on your own to do that. It's all written in Python, so you don't really have to do a whole lot of work to get it up and running. If you want to just use the source code directly from the master branch of OpenStack.org, you could absolutely do that. So right now they're on Mataka, which is M. It's essentially just OpenStack release M. And I think
that's source code only.
That's the source code version. Yes, the source code version's on Mataka, and then right now we're on release number 9, which relates to we use numbers instead of letters. It would have been a lot easier if we just used the same letter. I don't understand why anybody changes what. It's just confusing. It's intentionally confusing to people. They want to make OpenStack as difficult as humanly possible to learn and understand. It's the truth.
So we're so the Red Hat offering is 4 releases behind Mataka.
Yeah, I don't even know where in the numbering scheme. So the first few releases of OpenStack, nobody put together production software for. So that's why we started it at 1. That doesn't equivocate to their A.
Oh, okay.
Yeah.
Is there still a 6-month release cycle for OpenStack?
Yes. OpenStack has a 6-month release cycle. So every 6 months there's new features, there's code freeze, new features are jammed out, everybody fixes bugs for about 90 days, and then everybody starts working on the next generation of code for 90 days. And that's a really fast development cycle. 6 months for this kind of software is rapid, and features and APIs are constantly changing.
Then how long of a window do the vendors provide? Like what if you buy OpenStack, what's the supported timeline?
I know ours is 3 years. It's a 3-year supported timeline, but that's if you're building a cloud, that's even
The releases are end of life after a year.
right.
So
You need to, with OpenStack, so if you're going to use upstream OpenStack, use a source code or use a community project, so like, the Miranda's community project, they stop patching the back-end stuff. They don't go back or release and touch it. They don't go back and fix that.
You have to upgrade.
You have to upgrade.
Yeah.
You're upgrading. That's happening. That's definitely happening.
And that's kind of like Red Hat's business. There's a lot of other open source companies like that where we will maintain it beyond what the community activity was.
Right, we'll just backward
that
we'll
you
just
have
backward
some
patches and stuff like that. So
OpenStack
CCA does the
doesn't
same
really do a
thing.
long-term support.
What's that?
OpenStack doesn't really have a long-term support kind of model.
So they've been talked to several times about this. Like, you guys gotta at least put together at least one release that's supported for a little bit longer. And I want to say an LTS release is coming, but there's no LTS release right now. There is OpenStack Mataga, and pretty soon there will be OpenStack N, and I don't even know what the name of it is.
Because there's not many companies that are going to move every 6 months. There's just no way.
No, well, you could. It takes you 6 months to put one together and then test it and validate it, make sure it runs. I mean, if 6 months is a blink
They're doing
in the
everything
span
humanly
of production
possible
IT,
now.
right?
The
Yeah.
hands on deck they have.
It's the same thing that Fedora has done, right?
Fedora is-
Right. Who puts that into production? I think Fedora is great if your application is moving at light speed along with technology. So if you're an innovator out there, if you're an Uber or a Netflix, and you need to just drive forward light speed with the newest, latest, and greatest features, putting Fedora in production is a great idea for you because the software stack below your application is moving along with the application that you're driving. So it just depends on what kind of technology company you are. If you're an innovator, if you're a cowboy, if you're the ones that's moving ahead light speed and want the newest, latest, and greatest features. And doing this stuff's not that bad. I mean, you're used to it.
Well, those companies tend to also have crazy testing regimes. Like Netflix has, they're the ones that pay us.
Yeah,
right.
I know the
So
chaos
they'll like
monkey,
knock
yes,
down
yes.
entire regions of their system just to watch itself heal. Like, like they're pretty advanced in terms of, they're bleeding edge, but at the same time they have a lot of safety nets that are helping them.
Right, yeah.
tolerate it.
You're really talking about amortizing pain, right?
Right.
Because if you're staying on that bleeding edge, you constantly have pain.
Uh-huh.
And constantly having pain isn't a bad thing, but you have to pay for that in people and time. But if normally production IT companies don't have that, so you pay Red Hat, and you get a good value for your money because they give you like, okay, well you're going to be able to use this RHEL for 10 years, and that pain is amortized. And when you get to the point where you have to upgrade, we've already done a lot of work for you, so you only have to deal with the pain for your specific applications.
Right.
But for something like this, every 3 years,
But we have to be floating a lot of patches that if it's the 3 years, we're supporting it 3 years, but it's changed every 6 months.
Well, we do a lot of that upstream in our community. So the community will contribute some patches back, but they're not going to go like them. They're not back patching Kilo right now. That's not happening.
Yeah.
They're definitely not doing that because they're
Well,
busy.
Kilo may not even be accepting patches.
Right, right. Well, I mean, they already owe repos, so like you could go back and fix them yourself if you want to. So if you wanted to back forth those patches, that's all up to you. It's just Python. It's not that complicated.
I've seen that these companies have been missing.
It's not like C or anything. I mean, it's hard. C is really hard. I can't get it. I can't wrap my head around C. I just can't do it. So back out of the Neutron app. Provide you with software-defined networking, programmable infrastructure to create layer 2, layer 3, sometimes layer 4 applications or networks. Neutron will do load balancers as a service right now, so Neutron will do load balancers as a service, firewalls as a service, and pretty soon you're going to start seeing routing as well. So there is a BGP plugin available, so you can actually run a real routing protocol on Neutron, and this is kind of a fledgling plugin, but it does in fact work. The IPv6 stuff does work. The BGP stuff does work right now, where it's the first routing protocol you can put on a router, because routers are not really great without routing protocols, because having to go through and statically jam out every single route that may possibly exist is a terrible idea. It makes life very difficult. Oh, and I forgot VPN as a service too, so you can do IPsec VPN as a service. If that's all you're trying to get out of the cloud, or your enclave is all you want is just is software-defined networking, you could just put that part together and be good to go. You don't even need to use the virtual machines if you don't want to. So CINDER is the block storage provider for your cloud service. So block storage is persistent storage. Remember the Glance stuff that we talked about earlier? That puts things together in a bunch of layers. It might smash them together depending on whether it needs to or whether it doesn't need to. CINDER is persistent storage. So this is storage that will stick around even after your virtual machine dies. So we're going to go through a scenario where I have a virtual machine that is a web server that has a bunch of application data on it, and I have a database server as well. So I fire up these machines. The machine's disk itself that it copied in from Glance is ephemeral. So if that machine breaks and you shoot it in the head and get a new one, that data that's stored on that ephemeral drive, that image that you pulled out of Glance and put it into Nova to run your virtual machine, that data will not be saved without taking a snapshot or something along those lines. That's where CINDER comes in. It provides you that persistent block storage. So you connect another drive to this machine and maybe store or mount that drive to var www HTML, and all your HTML code will be stored there. And on the SQL machine, it's going to be connected. Your drive, this block drive, would be connected to var lib mysql/data, and all your data would be persistently stored. So if this virtual machine that this disk is connected to gets sick, I will get a new machine and connect it back to this block storage. My data would still be there. Any questions on that? It's kind of an important service if you want to see.
Logo.
So that's the bug logo. Ceph is used in 90% of production OpenStack deployments. People are using Ceph for their storage backend for a multitude of reasons.
The little bug.
This little bug here is Gluster.
It's Gluster.
This is Gluster. That's the Gluster ant that chews the leaf. Yeah, I don't understand the ant with a leaf and how that makes sense to the word Gluster. Maybe there's something I'm missing there. So CINDER is an API front end for several different back-end block storage mechanisms. Ceph being the most popular. Ceph provides you object storage / block storage, and you can scale and scale and scale and scale with Ceph. But some people, you could use just a simple NFS server. If you wanted to use an iSCSI server, you could just fire up a Red Hat machine with a bunch of local disks on it and use LVM and iSCSI, and that's included functionality right out of the box. You don't have to have.
Can you use cloud storage like S3 or Google Drive?
That wouldn't be good for block storage. That's not a good idea. S3 would not be a good idea because it's not really what S3 is for. You could maybe hook it back into EBS. I don't know if that driver is there yet. It was Elastic Block Storage. I'm not an Amazon expert. I would never claim to be an Amazon expert. I think we might have an Amazon guy in the room. So
you wouldn't be able to, unless you were provisioning the virtual machines on Amazon, you wouldn't be able to connect to those. That's what I use. But I can see if you had OpenStack tied into AWS, we were talking about the extending out, you can probably do that with those machines out there.
The AWS would treat it as an internal to AWS thing, and therefore it could talk.
you might be able to set up some way to replicate the volumes on the back end up to AWS CBS or something. So when your cloud bursts, all your data's there too.
Yeah, but so for example, you can use the S3 storage, right? So you can use URLs, but that would be more easier for static stuff.
Yeah, we wouldn't want to use.
So you wouldn't want to use it for this.
Right.
So what was that? There was another service which was.
Right, we'll go back over Swift again. Right. So the object storage. That's S3 would be good for the object storage. But this is persistent data. So your machine expects a disk to be connected to it. So via iSCSI, via NFS or something that's low latency. You would want to use low latency local storage, local to your data center storage mechanisms here. HP 3PAR supported. I mean, they've just got the back-end drivers for CINDER continue to expand and expand and expand and expand of what a supported back-end could be. And those back-ends are all written by those particular vendors, and they may or may not get a CINDER feature, so as it like something like encrypting a volume. So if you're concerned about your data and it's highly sensitive and you want to encrypt that data, you can make sure that you, when you set this service up in the configuration file, that you mark to encrypt everything, or just leave that as an option to your users. Do I want to encrypt this volume?
Talk to a Lux encrypted.
You could use Lux. You could use. I think Dell has an encryption mechanism. I know the EMC has an encryption mechanism where you just click the encrypt button, and the storage array will take care of the encryption. So CINDER provides the API to access that function.
So it pulls in the key and all that to ignore.
No, it just says it just gives it it would just give that storage mechanism the command encrypt this volume. So if you were talking about LVM, then the process would probably be set up this logical volume, then encrypt it, and then hand that over to me. So
when the data is flowing on the network, will be still clear. So if I scan,
data in transit information, you encrypt it differently.
Right. If that was of great concern to you, it would be connected via standard mechanism. So, however, like this is just the API, Cinder's just the API. So, however that storage device would be connected to a virtual machine with a given hypervisor, that's what you're going to get. This is just a standard front end for many different backends. So, like, let's say I wanted to buy EMC storage today, HP 3-part storage tomorrow, because EMC was cheaper today and HP was cheaper tomorrow. I could use the same API to access both of those storage mechanisms and connect them to my machines in a standardized way. So that way, I don't have to change my application. My application, when it gets overwhelmed or its disk gets full and it says, hey, I need another volume, go ahead and hook another volume up to me. It doesn't know or care that there's different storage backends available.
So I'm struggling with this, like at an implementation level. I'm trying to think of if a Nova virtual machine is trying to write something to Cinder.
Mm-hmm.
Is it happening? Like where is Cinder coming into play? Because it seems to me like the ext4 writes to the file system via some standard system calls that would then in a like a standard physical machine that would then be handed off to whatever driver to like write persistent disk. But like in a virtualized environment, like I just don't understand like where you can break that chain and like not have horrible performance penalties.
Okay, so I can explain that.
Is it they can connect them and then it's hands off, or is it? Well,
I will explain this. So the virtual machine that we're going to use the KVM hypervisor and LVM as the example of the backends for the front end of Nova and for the front end of Cinder. So the front end of Nova, its back end is going to be the KVM hypervisor. The back end of the Cinder service is going to be just LVM and iSCSI. So when the machine is provisioned, you've got a virtual machine sitting there on a hypervisor, and this is on one of the nodes within the data center or within your lab at home. If you were to go into the KVM hypervisor, it's easy to attach an iSCSI disk to that hypervisor. Right? So essentially what's happening here is the Cinder volume service, when you tell it to attach to a virtual machine, it would take and make an iSCSI connection from wherever the Cinder service is at. So if the Cinder service is on the controller and it's just a hard drive on the controller, it would make an iSCSI attachment to that virtual machine.
Okay.
So you would get the same performance as you got out of iSCSI.
So then KVM would like mount it.
Yeah.
All right.
It would mount it as an additional block device.
Like communication that they connect them and then it's sort of hands off and let the hypervisor do its thing.
Right, because this is just a front end for many different back
It's almost
end
like the
mechanisms.
SIP protocol inside a cloud.
So does Ceph have like a kernel driver associated with it or something?
Ceph, has drivers associated with it that if you use this as the front end, it would use.
It's an alternative to iSCSI or anything.
It's just the Rados gateway or honestly, I'm not a Ceph expert by any stretch of the imagination.
You have the VFS, right, in the Linux kernel, and then you have the Ceph, which attaches to that, which provides the file system to the operating system.
But the Ceph volume would just be attached the same way. I mean, if you were to go into Virt Manager and look at your available options to do something, like how can I connect a storage pool to this hypervisor, which may very well be my laptop. That same options. You're going to get the exact same options. There's nothing special about the OpenStack front end other than it provides a standardized API to access multiple backends.
So Cinder is really the API saying, this is what I want.
This is the block. I just need a logical volume. I need a physical block device. So this block device could be broken up any way I want it to be broken up, but the API that Cinder provides, because like I said, OpenStack is really a set of APIs that access underlying resources. There's no magic here. There's not really something special that's happening other than you make an API call and then several different actions occur. So if I said, Cinder, create a block volume using the LVM driver, it would go down to the logical volume manager, and off the Cinder volumes group that's been pre-created for you, it would create another logical volume. And then it would tell the iSCSI process, hey, iSCSI, make this as a part of your target.
So
those couple of actions.
It sounds like the magic would be in like a provider. So Ceph would have to plug in to implement Cinder's API.
The magic is in the plugin.
Yeah.
So the Cinder provides that API. The plugins provide the mechanism to access the resource.
Cool.
And those plugins go throughout all of OpenStack. So Nova has different plugins. NEUTRON has different plugins. So you could use like Mitakira if you wanted to use for NEUTRON. You can use a completely different network provider.
So you need to make sure you've installed all those plug-in packages that you need for your use case.
Yes,
Okay.
and you have to configure those plugin packages, and they're part of the OpenStack configuration files. So when you're calling out a plugin, it's a Python class.
Is that where
Okay.
most of the OpenStack work is going on, is in all the plugins and the compatibility layers?
Yeah, because I mean the API is complete. I mean, what do you want to do with the API? I mean, there's not anything you can't do right now with the API that you could do with any other service provider. As a matter of fact, most of the time, OpenStack is ahead as far as features are concerned and things that you can do of most companies or of most other providers that are out there. I don't want to say all of them because I don't know all of them that are available out there. You know,
So
Digital
then-
Motion might have something super cool I don't even know about.
So then it seems like the instability as these providers advance in their capabilities, the plugins have to catch up and it causes issues.
Absolutely, yeah. I mean, it's a huge thing because technology is moving ahead of some technology is moving ahead of light speed. How fast is block storage moving? Not fast.
So
At
how,
all.
how do vendors like differentiate them? Like how, if there's a standard API, and let's say you're a storage vendor and you've got some whiz-bang new feature, but there's a standard API, like how do you expose that? Do they just break the standard and say like, we're gonna make this API and we're gonna hope that OpenStack pulls that in? How does that process work?
That's kind of exactly how that works. So if let's say I'm HP and I've got this super sweet feature that I want to make available in Cinder, I would go to the Cinder API and I would write it myself. I would contribute that upstream to the OpenStack.org community if they accepted my pull request or whatever you want to call it, whatever they're using Garrett right now, so whatever mechanism they're using to call it, but I'll use the standard GitHub terminology. If they accept my pull request, then my stuff makes it into the API. It's available, so if there's a feature, and it's usually many
But that
different
feature's tied
vendors.
to a specific provider, so not all providers will see
It might be tried, yes. It might initially it might be tied to a provider, but it might make other providers be like, oh well, you know, EMC's like, oh, we're sucking on block storage today because we don't have this super sweet new feature like, you know, rate shape this connection. I don't know.
HP is pushing hard with the bare metal provisioning. So you install a server, right? So somebody has to go and install the OpenStack on it. So they're pushing this, saying that okay, you bring in, we'll give you interface to our ILO interface, the HP's interface and back to the servers, and then they'll use the OpenStack platform to deploy that physical server as well before you can start deploying any of the virtual machines.
Sounds similar to Canonical's Metal as a Service.
Right.
Yeah, and we had that. OpenStack has that too. The Nova Ironic driver will do Metal as a Service as well. That's actually how we deploy. That's how our deployment mechanism works, and I uncover that at the end if anybody's interested in hearing about how this is installed. There's one of the slides in here, and I really started to have to give you guys a slideshow presentation. I was hoping to get into the demo a little more deep. So we talked about Swift a little bit earlier. Swift is that object storage service. That the object storage service stores exactly what it sounds like, objects. It's accessed via HTTP protocol, so HTTP, HTTPS. You can use either one of those to store stuff as objects. You would say, you know, use get, post, put requests to get objects in and out of the object store. And on the back end, you can replicate that data. The default is to use rsync to replicate data. That's what it uses on the back end. Is the default, but you could use any type of provider, any sort of object storage that's available. S3 might be a very good candidate here if you wanted to make sure that you want to be able to like access resources in the cloud and make that a region or make that a very specific container or something like that. You could take Swift and connect it up to multiple object stores to store your data or replicate it across many different systems. Any questions on the object storage? I think we beat the storage stuff to death. As long as everybody understands, it's important to understand how it works because like these conversations are sometimes difficult to understand here. So can be got backed by Gluster stuff or Amazon S3. So this is also really good for replicating data. Like if I want to have the same image store across the world, and I use Swift as my backend for Glance, and I have Swift replicating from data center to data center to data center. That would keep my storage service alive. I could use this as now there's a whole bunch of applications out there right now that are able to use Swift as their backend. So if you think about things like OwnCloud can use the Swift container or object storage to provide you that UI. Is anybody in here familiar with OwnCloud? Anybody know what OwnCloud is? It's like it's a PHP application.
I know what it is, not a whole lot of details about it.
Yeah, it's just a PHP app that you can use to back up your computer or upload files. It's like a personal Dropbox.
What's it called?
So, yeah, it's like it's a clone of Dropbox. Yeah, that's a much better way to say it. So you could use Swift as a back end for all those objects, all your documents, all your pictures, movies, all your whatnot would use this back end. CILOMETER has now actually been broken apart into 2 different projects, but they're not important enough to talk about separately. So CILOMETER is the telemetry and metric service. So now they're broken apart into ADO and Noki, and nobody knows why they changed the name, or they can't just use CILOMETER meter and CILOMETER alarm. I mean, those are descriptive names. So CILOMETER is a telemetry service, and telemetry is important in the cloud, and this is actually kind of an important service to talk about, because when you think about doing things in a cloudy fashion, you're monitoring resources and then performing an action when a resource is exhausted. So if a virtual machine is sitting there at 0% utilization, I could have CILOMETER send an alarm, and the alarm could perform any action. The action could be kill that machine. The action could be tear down this application. You could take a CILOMETER alarm and have it do anything that you'd like to. You could have your applications listening to CILOMETER, so this app might not be aware of how much CPU it's actually using, or maybe you didn't write that code in there, you just didn't want to. It's easier to just call the CILOMETER API and say, hey, how much am I using right now? And I can get that data and then do something about it. So this is where my actionable data comes from inside the OpenStack cloud context. I get the actionable data from CILOMETER. It measures everything. It measures packets in and out of interfaces, measures CPU load, measures memory consumption, things of that nature. That's not an exhaustive list, but that's just the things I can think of off the top of my head. Any questions on the CILOMETER service? Okay. So heat is this is also almost not a train wreck. Almost not a train wreck. Heat is the orchestration service. So let's say I wanted to build an auto-scaling cluster of web servers. I would use Heat to do that. And you could hook Heat up to CILOMETER and get the alarms and feed it data to do that auto-scaling. So when my network utilization gets over a certain percentage, Heat is what would take action. So the actionable data came from CILOMETER, and Heat is the service that would actually do something. It would take action, and you write a Heat scripts, which are a very complicated set of YAML files. They've got some examples up there on GitHub to help get you started with the orchestration service. But you can also do things like, I want to define what an application looks like, and this application needs a network. This application needs a compute node. It needs a virtual machine. It needs a block device. It needs its own network, and it's going to need to be connected to the object store. So all of that stuff you would define within the Heat template to define that application, and you could just fire off doing all of those things at the same time. And Heat will call the other OpenStack APIs for you. So you don't have to go to the network service and click create new network. Okay, what's your subnet going to be? What's my router? I gotta create a router. Now I gotta create security group rules and things of that nature. Heat will just orchestrate all of that stuff for you. And there's a whole bunch of other services that are starting to come online that leverage Heat to perform actions. So things like big data as a service, or database as a service, or file share as a service are going to leverage the Heat API to orchestrate actions to occur.
In that mode, is there any connection, any interaction between Heat and Ansible, possibly?
So Ansible you could use Ansible to call the Heat API, but Heat's its own orchestrator, so you could just totally replace Heat with Ansible. You don't even need it.
But Ansible's not yet ready to talk to OpenStack, though. So
yeah, it is.
Sure.
Oh, absolutely. You can
So
provision
Ansible
things.
could listen to CILOMETER and do the same thing.
Ansible doesn't listen. Ansible is a push only. It is an I the user execute only. So you could have a listener. You would have to write your own listener, and then call an Ansible playbook once an event occurs. But it won't really. It'd be really hard to do things like auto scaling, like just create another one of these virtual machines, get another block volume, connect it up. Yeah, it would turn into a really big mess of an Ansible playbook where he'd already does it.
Does Heat include tooling to help you write the templates?
No. No, it doesn't include any tooling. It includes an API that accepts YAML files. People out there have written a whole bunch of. No, you got to jam out your own YAML file, man. You are on your own with Heat. You are on your own. The people who wrote it, they made it as difficult as humanly possible. This is my least favorite project because it is just the barrier to entry for it is just so high that like.
Is there even like a community site with sample templates? Or something?
Yeah, there is GitHub. Yeah, GitHub's got a ton of it. You have to run a search for if you search for hot templates, HOT, Hotel Oscar Tango, hot templates. There are a whole bunch of Heat orchestration templates. There's several examples for you to get started out there, but understanding what's happening, like having to say that there's a variable, declaring the variable, and then having to say it again at the bottom makes absolutely no sense. I don't understand why it is the way that it is, but there probably is somebody who knows way more about orchestrating services than me who does have it like that for a reason. So.
Hey, Patrick, is there an analog in is this like cloud formation for?
This would be cloud formations.
In my head,
Cloud
every
watch.
single thing you're saying, like I correlated to the Amazon service, and it's like, that's
That would be interesting, Patrick, as we're in, to say what your correlations are.
So you also have the CloudWatch API as well.
Yeah.
CILOMETER is CloudWatch and CloudWatch rules.
So the CloudWatch API goes into Heat. So if you wanted to get an API that was Amazon compatible for CloudWatch, you would do it along with the Heat service, not the CILOMETER service.
How does that make sense?
Didn't I say almost not a train wreck?
That's specifically template-based standing up of services.
So this is Heat includes several other APIs. It includes the CloudFormation API, and it also includes the CloudWatch API. They are in Heat. CloudWatch is not in CILOMETER. So everything in the OpenStack and all the OpenStack projects, they tried their best to replicate the Amazon APIs. A lot of them are, if they don't comply standards-wise with that specific API, they usually have an additional API that's available along with that service. So going all the way back to the Nova service, that includes Nova EC2 API, which is Amazon compatible. Will everything just yank it right out of Amazon and put it in OpenStack? I don't know. I'm not an Amazon professional, but it's supposed to work.
So if you want to run containers in your OpenStack stack, Heat is what plugs in Kubernetes. Like you can use the orchestration there. Like Kubernetes has a Heat plugin that you build, and you can connect it to OpenStack.
Sure, you absolutely could. If you're going to use your OpenStack for that, you could absolutely use Heat. I'm not familiar with doing that. But I know there's a project around Docker. I want to say it's Magnum. It's Magnum. This is a Magnum project out there for running bays, swarms, and Kubernetes pods on OpenStack, and it will just take care of provisioning all that stuff for you.
Red Hat's approach is different, where you layer OpenShift on top of OpenStack.
Okay.
So OpenStack is creating the compute nodes. So when your containers get saturated in your virtual machines, a Heat template could spin up an additional compute node, join the Kubernetes cluster, and have it host more containers in it.
Right, because you could go about doing something like that in two ways, making an auto-scalable. An auto-scalable platform as a service. So if with an auto-scalable platform as a service, you could use Nova Ironic to do bare metal provisioning for you, and Nova Ironic makes a piece of bare metal that's registered with the Ironic driver, makes it look and act just like a virtual machine would inside of OpenStack, and then you could use Heat to orchestrate OpenShift nodes on top of that, or just standard Docker containers. I don't know what kind of reporting you get back in OpenStack with the Magnum project, but I believe it's Magnum that does that right now.
It supports auto scaling.
It does support. You can be writing that yourself. You don't have to write it in Python though. You only need to write it in YAML. So like you gotta grab the alarms that you want. You register the alarms with CILOMETER. You gotta grab the alarms out of CILOMETER. You gotta do something with them. But all the data is all available via the API
Health checks
and the
all
services.
So
Yes, that's all it's supposed to do.
OpenShift has heat templates with OpenStack.
Have you fired up those heat templates? Why don't you go ahead and give those heat templates a try? Tell me how they work.
That's what you're saying.
Want to move on from heat. Trove database as a service. So databases are kind of how do you scale a database right now? What do people do to scale databases? That's the idea of the Trove project, is to provide database as a service, so people can just instantiate databases and not have to worry about how it happens. Like, I need a SQL database. I'm tired of going install MySQL-server. MySQL secure installation. Okay, I don't want to do that stuff anymore. So that's what Trove takes care of for you, is relational and non-relational database as a service. That's the idea behind Trove. Still, it's one of the younger OpenStack projects, so Trove still lacking in some features and some databases. It doesn't have everything available to it right now, but they're working on it. So here's some of the other services that I was going to talk about. There's Sahara. Sahara is so you could run like Hortonworks in your OpenStack cloud, or you could run Cloudera big data processes. And so Sahara is kind of its own project, but it really uses heat to do all of its provisioning. So all the stuff that would happen, so all the networks that would get spun up, all the virtual machines that would get spun up, Sahara would talk to the Heat API and say, hey, Heat, it's just a template builder for you. Like the automatic template builder, there's one. It's called Sahara. Manila is a shared file system as a service, so I could provide CIFS or NFS shares and just continue to scale those out. So it'll just provision virtual machines, attach block storage to them, and then configure the Samba server for you to continually scale your file shares. DNS is a service, so there's a couple of different companies out there that provide DNS right now as a public service, and you can use Designate to do so. And then Zager, I think it's Zager. Message queues as a service would just be RabbitMQ, I think. I don't really know anything about this one, to be quite honest. I've never set it up. Any questions on any of the other services? So there's like 75 different projects happening in OpenStack right now. If you go look at the unbelievably exhaustive list of things that are going on that are not in OpenStack core services yet, it's moving at light speed, and people are constantly coming up with new ideas of new APIs to write, because they're just APIs for a back-end provider.
I did have a question.
Go ahead.
About APIs.
Sure.
You mentioned using a message bus, Rabbit specifically, like at the front of the top with the big overview chart. And you described the APIs, and I imagine that some of the API interaction is this talking to it, or? Yep,
we're right there right now.
Okay.
It's a very timely time to ask that question. So it does. It uses RabbitMQ. So API call is made, and like I said, there's a front end API that sits on the controller node, and then depending on the service you're talking to, so like the CINDER API might sit on the controller, but the volume service sits on a completely different node. So it has to have a way to communicate in between the Python code that's actually doing something, so the Python code that's talking to the KVM hypervisor and getting feedback from the KVM hypervisor has to be able to talk back to the service that holds the API and say, yes, I did it, no, I didn't, I did it and it broke. And it uses RabbitMQ to send those messages, inter-process communication, back and forth. So the Nova Conductor service talks to the Nova Compute service via RabbitMQ. There's an API call made to say, fire up a virtual machine instance. The Nova Conductor is going to find a specific node to place that onto. It's going to send a message to that node saying, hey, spin this machine up, make it look like this. But it's going to do that via RabbitMQ, because there's no API for the Nova Compute service. It uses RabbitMQ, inter-process communication too.
So one of the cool things with that is AMQP, the Advanced Message Queuing Protocol, is a wire-level standard for messaging. RabbitMQ has not yet adopted, or they have experimental support for the 1.0, which is the OASIS standard. Once they adopt that, and that's incorporated into OpenStack, then any AMQP broker can be used. Like it's a wire level standard. So brokers from different vendors or different open source projects completely compatible with each other as far as what's traveling on the wire.
So I don't know that right now you can't just plug a different provider in, or you couldn't
Well, they're
very
using
easily write it.
0-9 or 0-10. They're not at 1.0 yet.
Well, I mean, you might be able on each service you in the configuration file, you might be able to just swap out RabbitMQ for some other message service as long as it can send a service back as a message back and forth. It's going to be sending the same. The messages aren't going to change. The mechanism in which they get there might be different, but it's all about support and who's done what. I know that there was another message broker that they supported for a while that started before RabbitMQ when they first came out with OpenStack that nobody really uses now.
Like 0MQ?
No, it wasn't 0MQ. I don't remember it off the top of my head.
So are there different layers of APIs? Because like if you have I'm guessing there's terminal clients that can interact. Like you talked about Horizon, you can go through the UI, but I know you can also go through a terminal, right? And issue API command.
You could use curl to issue API
I
commands.
presume that doesn't interact directly with Rabbit. It's probably over an HTTP layer. So is that what's happening? Like
Yes.
is the Rabbit queue calls for the inter-process communication like totally different APIs from
Maybe this would
front
be-
end HTTP stuff?
Can we turn on the lights for a second? It'd be easier to describe this.
over by the sink.
This would be easier to describe on the whiteboard. It's like I don't have a good diagram of this. So we've got our dashboard up here. / CLI. And we've got our API here. I know I'm gonna spell Q wrong. Don't make fun of me.
Just do MQ.
Just keep using use.
Yeah, that seems easier. And then we'll talk to the provider. This is a terrible diagram. Oh my god. So, this is Horizon. So if you do anything in Horizon or the CLI, they both talk to the APIs. That's exactly what Horizon does. Is it just makes API calls for you. It's not sidestepping any bit of this process. Everything that happens within OpenStack will either come from Horizon or the CLI to talk to the API. The API service, whatever's providing that service, is also connected to this message broker. This message broker is going to send a message across the wire internal to your data center, and then that message is going to be received on the listener on the other side, the RabbitMQ listener, and that's going to in turn talk back to this provider that's listening for messages.
So the difference, like the Horizon, the API is like an HTTP layer probably. And then
This is a
API.
dashboard. I'll show you the dashboard, but like right here, I would use curl. We'll just say curl. So if I wanted to use curl to call the API directly, I could just do
so
that.
that's HTTP, and then the
API
API layer
translates
translates it to a RabbitMQ message
Mhm.
that puts it in the box.
Whatever's implemented in that REST API.
Right. Does its thing,
Yeah.
gets into a message presumably at the end.
Mm-hmm.
All right, cool.
And then the MQ to MQ, that's all the MQP. That's the protocol that's being used.
Yeah. And you can go listen to these messages. Other applications can listen to these messages. So applications like Manage MQ, you can give them direct access to this layer right here. So they don't, that